Hello everyone, welcome back from the weekend. We are going to be going over the Hamilton's method and the Jefferson's method again in today's lesson. Just based on the quizzes from last week, it seemed like we struggled with the difference between those two methods and the paradoxes, so we're going to talk about those today again in hopes that maybe a reteach will help solidify these ideas further before we continue on with a new apportionment method. All right, so I'm going to run through them again here and maybe talk about some of the common mistakes that might have been made on the quiz. All right, so let's look at this first problem. It says a college offers tutoring in math, English, chemistry, and biology. The number of students enrolled in each subject is listed below. So we have the populations for each class here. So I'm going to go ahead and just write those in here where it says population. So 330. We got 265 for English, 130 for chemistry, and 70 for biology. And it says the college can only afford to hire 15 tutors. So they've got some money that they're going to use to hire tutors with, and they're not sure how many tutors, like how many math tutors to get, English tutors, chemistry tutors, biology, so forth and so on. So to figure that out, they're going to use an apportionment technique to apportion the tutors to each subject based on the number of students in each subject. Okay, so the first step here to doing Hamilton's method is to take all of our populations here and add them up to get a total. All right, so we would get 795. If I were to add these up, I would have 795 total students. So now the next thing, if I want to find the divisor, I have to take that 795 and divide it by the number of tutors I'm going to hire. So I would do 795 divided by 15. And I would get 53. Okay. All right, now, next step, find the quotas. All right, so quotas is our next column here, and to find my quotas, I would take the individual populations from each class, and I would divide by the divisor. So I would do 330 divided by 53, and my first quota here would be 6.2264. And this was a common mistake that happened on the quiz. There was a lot of rounding errors. So make sure if it says round to 4 decimal places when you do your quotas, make sure you round to 4 decimal places. So you count over 4, 1, 2, 3, 4. Then you look at the fifth number, whatever that is. If it's lower than 5, you leave it alone. If it's higher than 5, you raise it up. All right, so if it were 3 decimal places, you would go 1, 2, 3, then look at the fourth number and do the same thing. So this is a 4. So this 6 is going to stay where it's at. If this were 5 or higher, this would go up to 7. Okay, so just seemed like there was a lot of rounding errors on the quiz, which caused a lot of mistakes to happen. And a lot of times with Hamilton's method, determining who gets the bonus person at the end, those decimal margins can be really tight. They can be really, really close. So you have to carry so many decimal places to see who actually has that bigger decimal portion. All right, so that's why it's important. Let's do English real quick. So we're going to do 265 divided by 53, and you should get 5 on the button here. So 5.0000, right, carrying my 4 decimal places here. Chemistry 130 divided by 53, so we would get 2.4528. And then 70 divided by 53 is 1.3208. Okay, so those are what we would call the initial quotas, and what Jefferson said to do with these was to chop off the decimal portions and ignore them for now. So my initial quota, or what we call the lower quota, is going to be 6, 5, 2, and 1. Okay. Now, we would add those up. Oops, and I wrote something wrong here. We would add up those lower quotas, or those initial quotas, and we would see how many we have, right? So 6 plus 5 is 11, 11 plus 2 is 13, 13 plus 1 is 14, but we need to apportion 15, so there's one bonus tutor, and the bonus tutor is going to go to the one who has the highest decimal portion after the whole number. All right, so this one's a 0.2, 0.0, 0.4, and 0.3. So the 0.4 is going to get the bonus tutor. So this 2 goes up to a 3, and the rest stay the same. So 6, 5, 3, 1, and when I add those up, we get 15. Okay, so now here in number 2, what we're going to do is we are going to reapportion the previous problem with Jefferson's method, right? So we're going to use a different method, but same information. And nothing has changed other than the method that we are going to use here. All right, so if you recall, Jefferson's method had what was called a modified divisor, and we'll talk about that in just a minute. All right, so our populations are the exact same as the previous problem, which means the total is the exact same, which means our divisor, right? So if I were to write my divisor that I use for this one up here, we would still be using 53. Okay, so I'm going to do 330 divided by 53, 265 divided by 53, 130 divided by 53, and 70 divided by 53 to get my quotas. And we've already done that work. We did that work when we did the Hamilton method just a few minutes ago. So all I have to do is copy down my quotas from the previous problem. So I've got 6.2264, 5.0000, and then 2.4528, and 1.3208. And then I'm going to go over here to my initial, and we would chop off those decimal parts and see what we have. So we have 6, 5, 2, and 1, which add up to give me 14 tutors. And we know that 14 isn't enough because we have to apportion 15. But Jefferson doesn't go back and award to the highest decimal value. So this final column is not needed for Jefferson's method. Instead, what Jefferson said to do was to go back to our divisor and change the divisor. So if we didn't apportion enough, we would lower the divisor from the original divisor. So it's at 53. So I'm going to say my new modified divisor, I'm going to lower it down to 45. And I want to see if 45 would create quotas that work. So now, after I've modified my divisor, I'm going to go through and I'm going to do those divisions again and see what my new quotas are. So I do 330 divided by 45, then 265 divided by 45, 130 divided by 45, so forth and so on. So here's what we get. If I do that first one, I get 7.3333. For English, I'm going to get 5.8889. So notice I'm trying to stay consistent with how I round to that fourth decimal place, right? And then 130 divided by 45, I got 2.8889 again. And for the last one here, 1.5556. So there's my quotas. And then I'm going to chop off those decimal parts and say 7, 5, oops, I don't know why I keep getting my 5 mixed up here. So 7, 5, 2, and 1. So 7 plus 5 is 12, 12 plus 2 is 14, 14 plus 1 is 15, and that's what we needed. And again, we don't need that final column for Jefferson's method, right? It's always the initial. Okay? So notice that when I lowered my divisor down to 45 and I took those initials, I got exactly what I needed. So this is the divisor that I would use. Okay. Now, if it didn't work, I would have to go back and try a different divisor again. And that's the part that kind of sucks about Jefferson's method, is that it's a lot of trial and error. Sometimes you go too far, you lower it down too much, and you have to raise it back up. Sometimes you don't lower it down enough, and you have to go back and lower it again. Right? It's not an elegant method. All right, it was never intended to be. The reason that Jefferson's method prevailed over Hamilton's method was because of those paradoxes. Those paradoxes just didn't occur with Jefferson's method. All right. So speaking of paradoxes, let's take a look at number 3. All right, so we have a store that is trying to assign people to work specific shifts based on the number of customers that come in during those shifts, right? Which seems smart. You would think that if you had 515 people coming into your store in the evening, that's where you want most of your employees working, you know, versus the morning that only gets 95 customers. So an apportionment method would be handy for a situation like this. Now, we are apportioning 20 salespeople here, and we have our populations listed, so I've already populated my column with the populations. All I need to do is add those up and find my divisor. So if I add up my 4 customer populations here, I get 795 total customers throughout the day. And then I would take 795 and divide by 20. And that gets me, let's see here, 67.5. for my divisor. Now I go through and find my quotas, so I would do 95 divided by 67.5, and I would do the same thing with each of the different shifts. Okay? So my first quota here is going to be 1.4074. And then we got 4.5185, 6.4444, and then 7.6296. All right, and then in Hamilton fashion, we're going to chop off those decimal portions and get an initial here. So we got 1467, and then I add those up. So that's 5, 11, 11 and 7 is 18. We need 20, so there's two bonus salespeople here. So I go to my decimal portions, and evening has a 0.6, so that's the highest one. So evening is going to get an additional salesperson, and then the next highest decimal portion is the 0.5 here in the midday, so they're going to go from 4 to 5. There's my two bonuses. The others stay the same, and when I add those up, I'll get 20. Okay. So now let's go to this next part. So it says reapportion the previous problem if the store has 25 salespeople. So now instead of 20, we go to 25. So they increase the number of salespeople. And I also noticed down here it's asking, did any of the paradoxes occur? All right, so this is important here, right? Because once you see this question, there's a potential for a paradox to occur. You can instantly identify which paradox you think might occur based on the situation. So nothing else changed other than the number of salespeople. So if a paradox is going to occur, it's going to be the Alabama paradox. I'm not saying that it has occurred yet. I'm just saying that's the only one that could. They didn't create any new shifts, so there's no possibility of a new states paradox, and they didn't give me any information about the growth of customers from one day to the next or one time period to the next. There's no way that I could figure out if a population paradox occurred. The only one that could occur here is the Alabama paradox. And for that to occur, one of the shifts would have to lose one of their salespeople, even though the number of salespeople increased. Okay, so let's see if that happens. So now I got to find my divisor. The total number of customers is still the same. We have 1350 here, so I'm going to take 1350 and I'm going to divide by the number of salespeople, which is 25, and that gets me a new divisor of 54. And I think I messed up back here. This should have been 1350. I don't know why I wrote down 795. It's probably from the previous problem. There we go. Sorry about that. You probably are wondering, man, he made a big mistake in that last problem. I caught it though. All right, so here we go. So now we're going to take that 54. I'm going to go through and I'm going to divide each of the different shifts here. So 95 divided by 54 is 1.7593. And then we have 305 divided by 54, that's 5.6481. And then 8.0556. And then 9.5370. Chop off the decimal parts, we got 1, 5, 8, 9, so that's 6, 6 and 8 is 14, 14 and 9 is 23, which gives us 2 bonus salespeople. So the highest decimal portion is the 0.7 up here, so this 1 is going to go to a 2. The next highest decimal portion is the 0.6, so this 5 is going to go to a 6. There's my 2 bonuses, and the 8 and the 9 are going to stay the same. That gives us a total of 25 salespeople. And now to determine if the Alabama paradox has occurred, so what I'm going to do here is I'm going to take a look at both apportionments. So for the Alabama paradox to have occurred, the original apportionment that we got up here with 20, one of these numbers would have to go down here when we apportioned with 25. Okay, so notice in the morning shift we went from 1 to 2. That's okay. They went up. It's okay to go up. Okay, midday went from 5 to 6. That's okay. Afternoon went from 6 to 8. That's okay. And evening went from 8 to 9. That's okay. No one went down, so no paradoxes occurred here. Okay? So no. No paradoxes occurred. And if one was going to occur, it would have been the Alabama paradox, but it did not. All right, guys, that's it for today. If you have any questions, make sure you ask in Zoom chat. I would love to clarify anything for you. Tomorrow we are going to move on to a new apportionment method and get ready for our quiz at the end of the week on Friday. All right, guys, have a great day.